So today then we are looking at finding the nth term of a quadratic sequence. Okay, so that posh right there, the quadratic. That just means with these sequences, there's going to be an n squared somewhere. Okay, quadratic, think squared, so we need to be sharp with our square numbers. So square numbers, 1, 4, 9, 16 and 25. Obviously they do go on. Okay, how do I get them? 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. Okay, make a note of them before you even start because we're going to be using these for every single question. So let's have a sequence then. Here's my sequence. We need to find the nth term of it. So whenever you see a sequence, the first thing you have to do is to calculate the difference. Okay, so here we have a difference of 3. We then have a difference of 5, and then a difference of 7, and then a difference of 9. Okay, now with the basic nth term, you would just look at the difference and then put that in front of the n, and then off you go. However, you will see that this difference is increasing. Okay, soon as you see that, that tells you it is quadratic. Okay, whenever it's increasing, sorry, the difference is increasing or decreasing, then it has to be quadratic. Okay, so now we need to work out how many of these n squareds are going to be. Okay, remember quadratic n squared, we know that's going to be there somewhere. Now we need to work out how many of them. Okay, is it going to be 2n squared? Is it going to be 1n squared, 3n squared, 4n squared? Okay, that posh word is coefficient. The coefficient of the n squared, how many of them? So for that, we need to work out our second difference. So the second difference here is 2. Second difference here is 2. The second difference here is 2. Right, we now have a constant difference. Whatever this number is here, you must half it. Okay, half of 2 is 1. So therefore, we know we're going to be using 1n squared. However, we don't use the 1, we can use just n squared. So that's the first part of our sequence. We know that this quadratic sequence contains n squared. So n squared is going to be 1, 4, 9, 16, 25. These are our square numbers we wrote down earlier. Now we're looking for a relationship from n squared to our original sequence. And you'll notice to get from 1 to 4, we add 3. To get from 4 to 7, we add 3. From 9 to 12, we add 3 each time. So the nth term of this sequence is n squared add 3. Okay, look at the difference. Second difference, half it, that's for our coefficient. And then find the relationship again. Let's try another one. -5, -2, 3, 10, 19. First things first, let's calculate our difference. Difference there is 3, then 5, then 7, then 9. Okay, it's going to be quadratic because my difference is increasing. How many of the n squareds are there going to be? That's the second difference. From 3 to 5 we add 2. Add 2 from 5 to get to 7, and add 2 there. Second difference, we have to half it, which equals 1, so we know it's going to be n squared. Okay, just 1n squared. So n squared is 1, 4, 9, 16 and 25. Let's look for a relationship then to get from 1 to -5. Could use a number line. Let's get from +1 to -5. There's a difference of 6. Okay, we're taking away 6. Here we are taking away 6. Here we are taking away 6. So we know it's n squared. Then to get from n squared to our original sequence, we subtract 6. And there is our nth term of this quadratic sequence. They do get a little bit harder, intermediates here. Let's have a look at this one. So, first things first, difference. The difference of 7 and 16 is 9. The difference of 16 and 31 is 15. Difference here is 21. Difference here is 27. Okay, if you couldn't do that in your head, you could easily just do 52 take away 31, 21, or 79 take away 52, 27. Use a column method if you need to. Okay, increasing difference we know is quadratic. It's definitely going to be an n squared there somewhere. But how many n squareds? Second difference then, you can see is 6, and 6, and then 6. What do we do with the second difference? We half it. Half of 6 is 3. So we know we are using 3n squared. Okay, we know it's going to be n squared because our difference was increasing. How many? We know there's going to be 3n squared. Now you wrote down the n squared sequence earlier on. Okay, 1, 4, 9, 16, 25. We now need to write down our 3n squared sequence. So 3 times 1 is 3. 3 times 4 is 12. 3 times 9 is 27. 3 times 16 is 48. And 3 times 25 is 75. So this here, this sequence is 3n squared. Okay, just to show you, n squared is 1, 4, 9, 16, 25. You can see I just times them all by 3 to make 3n squared. So then let's find our relationship to get from 3n squared up to here. Well, to get from 3 to 7 we add 4. To get from 12 to 16 we add 4. 27 to 31 we add 4. So the nth term is our 3n squared. And then add 4. So there are quite a few steps. It is tricky, but again, practice makes perfect. Hope it helps.